A coin is spun 3 times. So the probability of getting hit for each time we spin it is half. And a dice is rolled 3 times, and the probability of getting 2 each in each roll is 1/6. So the question is that their probabilities remain constant in each trials, meaning for coins the probability of getting hit is half, and then we spin again another half, and we spin again another half. And for dice, the first probability to get phase 2 is 1/6, and then we roll it again, we get 1/6 for getting 2, and another 1/6 probability of getting 2. So do they fit binomial distributions? So let us start. Hi, my name is Dr. Kat. In this lesson, we will learn about the binomial distribution in the subtopic of graph. At the end of this lesson, you will be able to construct a binomial distribution graph. Okay, let us start. So consider a series trials which are independent, have only 2 possible outcomes with probability P and Q, or Q is equal to 1 minus 4, 1 over P. Okay, there are only 2 possibilities. So if P remain constant for each trials, the trials are known as Bernoulli trials. So for example, if we have a coin, okay, so for the first trial, you get head. So you get half is half. And then for the second trial, the probability of getting a head is also half, right? So whenever you spin it, you will always get the probability of half of getting heads. So it means that the probability remain constant. Okay, and then suppose that we define head as a success. So that means half. So another success, so this is defined as P equal to half, and the failure as Q, which is 1 minus half, so it should be half. Okay, so this kind of trials, it is called as a Bernoulli trials. For another example for this is on off, male, female, alive or dead, or even for the dice. For example, if we define the success as a probability of getting 2 each time we roll it, so it can have 1/6 for a success, and failure as 1 minus 1/6. This is 5/6. So every time we roll the dice, so the probability of getting 2 is remain constant, 1/6 for every trial. So this is an example of what we call as a Bernoulli trial. Okay. Okay, so since Bernoulli trials only consider 2 outcome, either success or failure, so we can summarize them as in this table. So for the failure, it is 0, so you have a Q, and then for success, you have a outcome 1. This is equal to P. So the probability of P plus Q is equal to 1. Okay. So for example, you have a 10 spin of a coin. So you may have, for example, head. So for I times, and another remaining trials 0 0 0 for n minus I times. Okay, so the probability of getting this success, okay, the probability is equal to P power by I, and then the probability of getting the failure is Q n minus 1. Okay, so this sequence of getting 1 1 1 1 0 0 0 is equal to the multiplication of the probability pi power by I and probability of failure power by n minus 1. So this is the probability of having this sequence 1 1 1 0 0. But we may have also another possibility 1 0 1 0 and so on. So we can have many combinations, what we can say. So we can have many combination of sequence of this failure of or success. So in that case, if we have x is the random variables of the number of success in n trials. Okay, so if we have many trials, and then x is how many we get success in that trial, so we can calculate the probability for that success to occur is equal to the probability of that success to occur, which is equal to the combination of sequence. So this is the combination of sequence multiplied by the success power by I trial multiplied by the failure power by trials minus specific sequence. Okay, so this expanded to this factorial form, and we can actually calculate the possibility for the random variables to occur by calculating this. So this is called a binomial distribution. So this is called the binomial, which has the which has a probability of the given function. So this is the binomial distribution. So how it looks like. So let's look. Okay. So for example, here are three binomial distribution, and binomial distribution is specified by how many trials and the probability of success. Okay, the probability of success must be constant, so that is the requirement for binomial distribution, which is also Bernoulli trials. Okay, so we can write down the binomial distribution B in the bracket of how many trial and how many probability of a success to occur. So if we have for example 10 trials, okay, for example 10 trials, and then the probability of each success in each trial, the probability of success in each trial is 0.3, 0.5 and 0.7. So by calculating here, by calculation of here, so for example P0, so for to calculate the 0 is equal to, so this is we can use 10, and then so we can write as C 10, okay, and then I P power by actually this is 10, this is okay, so this is I, okay, and this Q as 10 minus I. Okay, so when we calculate for each of the xi, so we can have these three distributions. So this distribution are having the same number of n but different probability for each trial. Okay, so for 10 you can so for 10 trials, okay, so yeah, okay, so you can see that if the probability is higher, so the distribution shifted to the right. So that is the effect of different probability or in each trial. So let's look at the example. Okay, in this example, 3 dice are rolled simultaneously. What is the probability that 5 appear with the third face showing a different number? So suppose that x, we define the random variable is the number of success. So 5 appears in a simultaneous roll. So it can appear in 3 times of rolling. It can appear none, 1, or twice, or triple times. Okay, so the number of trial in each roll n is 3 because we have three roll. Okay, 1 2 3. Okay, 3 dice. We can also have a 3 dice. So the probability of having 5 in each trial is 1/6. right? Because we have 6 faces. Okay, so therefore we can have a binomial distribution of 3 comma 1 over 6, because we can characterize binomial theorem distribution as n and p. So we need to determine x equal to 2. That means at least 2 5 will appear. So at least 2 5 will appear. So which is also we want to calculate p2. Okay, so by using the formula here, we can calculate 3c2, and then 1 over 6 is the probability of success. This is probability of failure. So by calculation, we will get 0.069. That means about 9.6% chance of getting the 2 5 will appear. Okay, so let us continue. How can we construct a distribution graph for this case? So if you calculate for none of 5 will occur, or once 5 will occur, or twice, which we calculated before in previous slide, or in each row we get all 5, so we will get the probability of getting that by using the this calculation is like this. Okay, so and then from here we can actually make a graph. So this is actually not related, later actually in the next lesson. So we can plot this into this distribution graph. Okay, so when you multiply this or when you add all this number, actually you will get equal to 1. Alright, so next let's go to the teaser. A coin is spun 3 times. The probability of getting head is 1 over half, 1 over 2, and the probability of getting 2 is 1 over 6. So in this case, actually the probability remain the same. This is p equal to half. This is also p equal to 1 over 6. And for the failure, q is equal to half, and this is the failure, q equal to 5 over 6. That means not getting 2. Alright, so we will go further with this binomial distribution in the next lesson for expectation value. Okay, bye.